Okay, guys, today we're going to be working on some 3x3 system word problems. I know we already went over these, but just kind of a quick recap. I'm going to do a problem with you guys here. So if we take a look at number 1 right here, it says the sum of three numbers is 16. So you can use whatever variables you want, but I'm going to use x, y, and z. So I'm going to do x plus y plus z equals 16. And if you remember these problems from during the year, they can be quite extensive, so you're definitely going to want to write small here because you know it's going to be a pretty long problem. And that's for this first sentence right here. The sum of three numbers is 16, so x plus y plus z equals 16. Then it says the largest number is equal to the sum of the other two. So it's talking the largest number. So what I'm going to do next is kind of an optional step, but it makes it easier to organize things. I'm going to say that x is the smallest number. Y is going to be the middle number, or the second smallest, or the second largest. And z is going to be, z is going to be my largest. Okay, so my first equation was x plus y plus z. Now I'm working on this second part right here. The largest number is, we know is in math means equals, so is equal to. So the largest number is z, so we have z equals the sum of the other two. Well, sum means add in math, so we're going to do z equals x plus y. That's my second equation. And my third one is going to come from this next part right here, which is 3 times the smallest number is 1 more than the largest. So we have 3 times the smallest, so 3 times x means equals. 1 more than means plus, so 1 plus the largest, which is z. So now I have my three equations. I have my first equation, my second equation, and my third equation. Okay, so now it's time to start thinking about how we want to actually approach solving this to get those three numbers. So the first thing I see here, and there's a few different ways you could do this problem right here, but I see that z equals this. So right away I'm thinking substitution. So I'm going to take 2 and substitute that into equation 1. So I'm going to take 2, use a different color, and substitute that one into 1. So I'm essentially taking this right here and plugging that in for z in equation 1. So now what I have is, that is x plus y plus x plus y equals 16 once I make that substitution. And if I simplify that, x plus x is 2x, and y plus y is 2y. So there's my simplified equation right there. Well, now I want to get another one in terms of x and y so that I could use elimination and get one of the variables. But if I look at equation 3 right now, I notice that it's in terms of x and z, but I want it in terms of x and y. So what I'm going to do is I'm going to make another substitution, and I'm going to take equation 2, and I'm going to substitute that one into equation 3. Remember, when you're solving 3x3 systems, you have to eventually use all three equations. So what I'm going to do here is I'm going to take equation 2 and plug that in for z in equation 3. So when I do that, I have 3x equals 1 plus z, but remember, we're replacing z with x plus y. Now what I want to do is I want to move that into the same form as this one, so eventually I could set up elimination. So what I'm going to do is I'm going to move, x to the other side, and I'm going to move y to the other side. So now on the left side of the equation, I have 3x minus x, which is 2x, minus y equals 1. So now here are the two equations that I'm going to be working with. They're both 2 by 2. So now if I have a 2 by 2 system, this becomes an easier problem now. I could either do basic elimination or basic substitution, get my answer. So I'm going to write that one over on the left side here. I have 2x plus 2y equals 16, and 2x minus y equals 1. So again, there's a few different ways to do this problem right here, but I'm going to choose elimination, and I'm going to try and eliminate the x's. So what I'm going to do is I'm going to multiply the top equation by -1. When I do that, I end up getting negative 2x minus 2y equals negative 16, and then I'm going to add these two equations vertically. Notice when I do that, the x's cancel out. That's the whole reason I multiplied by -1. -1 plus -2 is -3, and 1 plus -16 is -15. And now it's a one-step equation. Divide by -3 on both sides, and you end up getting that y is equal to 5. So I know that the middle number here is 5, and now I need to find the other two numbers. So I don't want to go back to one of the equations with 3 missing variables. I want to go to one of the equations here on the right side that have 2 missing variables, because if I could plug the y in there into either one of those, I'm going to get x right away. So I'm going to choose the bottom one, but you could choose the top, it doesn't matter. So I'm going to choose this one right here. And if I plug in 5 for y, here's what happens. I end up getting 2x minus y, well, we know y is 5, equals 1, and then I just have a two-step equation. Add 5, and divide by 2. So now I know that x is equal to 3, so the smallest number is 3. And now I'm going to use the original first equation that we created here, x plus y plus z equals 16. The sum of the three numbers is 16. Well, if I know that the middle number is 5 and the smallest number is 3, their sum is 8. And if the sum of all three is 16, if x is 3 and y is 5, it's pretty easy to see that z is just going to be 8. Or you could solve the equation if you like doing that better. And then I can see I have z equal to 8. And now I have my three numbers. 3 is the smallest, 5 is the middle number, and 8 is the largest number. So find the three numbers. The three numbers are 3, 5, and 8. And that is it for this problem. Hopefully that helps you guys to complete the rest of the problems. If you're having trouble with any of them, make sure you reach out to your teacher on iTunes U or email them.